Good afternoon. This is Dr. Frank Wong, Green Solutions Team Specialist here at Bayer Environmental Science, and welcome to our third seminar for the Bayer Beyond the Basics webinar series. And today it's a real pleasure to have good friend and colleague, Dr. Mike Richardson, Professor in the Department of Horticulture at the University of Arkansas, presenting on the topic today of turf gadgets. Maybe this is rocket science. Just a few housekeeping things before we get started today. As far as webinar instruction, if you are listening as a group, please make sure that each individual signs into the webinar or email Natalie Sabonia. Her email is listed there with additional attendee names to ensure all participants receive credit for attendance. As previously mentioned, all participants are in a listen-only mode, so if you have questions, please use the little box on the lower right-hand side of your web interface to type in a question, and we'll assign those to myself or one of our team, includes Jimmy Johnson and Lawrence Mudge here, who will be asking the questions for you to Dr. Mike Richardson. And if you have any kind of technical difficulties during the presentation, you can also submit your problems and questions there in the Q&A panel. Okay, just a reminder, as far as the rest of the series or of our webinars this year, on Tuesday, June 19th, we're going to be addressing a very hot topic of turfgrass management, and that'll be Dr. Rick Lattin talking about bacterial decline of creeping bentgrass. And then we're going to take a break there in the summer because everyone's going to be busy like heck, keeping their turf looking tip-top. And we'll resume again on Tuesday, September 18th with Jim Kearns from the University of Wisconsin talking about snow mold and winter damage prevention. And then on Tuesday, November 13th with Mr. Steve McDonald speaking on new technologies for reducing water requirements and promoting plant health. Okay. As far as continuing education credits with GCSAA, you will receive 0.1 CEUs today. And to receive the credit, you have to submit the approval code to GCSAA within 30 days of this event. And we'll be providing that code at the end of the webinar today. If you have any questions about receiving CEUs, please email Natalie again there. And that's natalie.sabonia@globalprairie.com. You can send her any questions or issues about receiving CEUs. And most importantly, for you Bayer Accolades fans, you will be receiving 2,000 points for each webinar attended. And if you have the ability to view any 2012 webinar you missed in the series, you will receive 1,000 Bayer Accolades points. And if you attend 4 webinars throughout the series, you'll receive 4,000 bonus Bayer Accolades points. So, okay. So without much further ado, it's my pleasure to introduce today's speaker, Dr. Mike Richardson. He's a professor in the Department of Horticulture at the University of Arkansas, where his research is really focused on cultural practice that impact cool and warm season turfgrass production. In addition to being actively involved in research to screen and develop new fungicides, new turfgrass for a wide range of turfgrass environments, Dr. Richardson has served as the editor of Applied Turfgrass Science and an associate editor for Crop Science. Dr. Richardson is an active teacher and advisor in the Department of Horticulture and is the primary instructor for Introduction for Turfgrass Management, Golf and Sports Turf Management, and Golf Course Operations. So with that, Mike, please take it away.
Okay, well, thank you very much, Frank, and I want to just thank Bayer for inviting me to participate here today in the Beyond the Basics seminar series. And so hopefully you will walk away with some little tidbit of information this afternoon that can help you back at your facilities. Now, I will admit that this is some new territory for me because typically my colleague and I, Doug Karcher, we teach an 8-hour seminar on gadgets and gizmos at the golf industry show every year. And so we're going to try to cover at least part of that 8 hours of content in about 45 minutes this afternoon. So we're going to hit some high points along the way, and certainly not going to be able to cover everything that we cover in that seminar, but would encourage any of you that are interested in this type of topic in the years ahead to maybe look at that as a potential education program for you if you're attending the golf industry show. My contact information can all be found at our web address, which is listed there, and I'll also provide that information again at the end. So anything pops up today that we don't get answered, or if you have another question that comes up a week from now, don't hesitate to just give me a shout, and I'll be happy to try to answer that for you. Okay, so now we're talking about gadgets and we're talking about technology, and so I'm dating myself a little bit here by showing a picture of Captain Kirk and his comrades here from Star Trek, but really when I was a kid, you know, we watched television shows like this and we saw technology that just seemed beyond the realm of anything that we could ever imagine, but in today's technology-driven world, as it says here on this slide, even phasers may seem like old technology to some people, and certainly technology is coming at us today at a faster pace than any of us can keep up with. So again, I'm learning every day about new technology and how we might be able to use it, and certainly when we teach these types of courses, I usually learn as much from the participants because they've stumbled upon something that also works very well for them, and then we can hopefully apply that into future seminars. So again, you know, gadgets, toys, technology, it's all around us, and I'm sure probably everyone on this call has either got a smartphone or a tablet, or they use a GPS in their car. Again, there are all kinds of technological advances that have really just become routine, everyday applications for most of us. So again, it's a rapidly changing, rapidly evolving area, and certainly as turfgrass managers, every chance you get, because again, in some cases they certainly can help you do a better job of managing your turf as well as making decisions about managing your facility in general. Okay, so what are some things that you might be able to put to use today to benefit your management? And so I've just listed a few things here, and again, we're not going to cover all of these today. We're going to hit a few of these, but again, there's some really good technology available right now for taking soil moisture measurements, other types of environmental measurements, whether it's light, temperature measurements, things such as that. There's really good technology from a computing standpoint and GPS technology to record and map data so that you can take data that you're collecting and put it in a useful format that you or in talking to your members or your committees and things like that, you can make that data more compelling to them. So again, we're going to touch on a little bit of that today. Technology for measuring green speed, technology for measuring areas on the golf course, mapping golf courses. Again, we're not going to cover all of those today, but we're going to hit a little bit on just about all these topics. And then probably the thing that we've added the most to our seminars over the last couple of years, and again, we're still just scratching the surface on this, is what I consider to be kind of emerging technologies for your phone. And I know some of you probably have already taken in some of that technology and are using your phone for things that you really never dreamed of 4 or 5 years ago when a Razor flip phone was considered high tech. So again, things have really changed a lot in that area in the last 4 or 5 years. Okay, so we're going to talk today, kind of talking about a technology that's not necessarily new, but it's a technology that's certainly much more readily available to today's turfgrass management, and that's for measuring soil moisture. Now, before we get into what the tools, I want to at least give you a little bit of background information so you understand what kind of data you're actually getting from this type of instrument. And so this is, again, I know this is everyone's favorite topic when they took a good soil science class back in school somewhere, is the topic of water potential. And water potential is basically just the amount of work that's required to move water, and that it refers to both water movement in soils as well as water movement in plants. And so we measure that as a pressure. And so when we're thinking about taking water out of a soil, there's a certain amount of pressure that is required to pull that water from the soil and get it into the plant where the plant can need it. And so when a soil has a lot of water in it, it requires very little suction or very little pressure to pull that water out. So if we were at saturation or a term called field capacity, it doesn't take a lot of energy or pressure to pull the water out. When the soil dries to the point that the turf starts wilting, and we call that in soils the wilting point of the soil, at that point, we basically, the amount of energy or pressure required to pull water from that soil is so great that the plant can't actually create or generate that much energy, and so the plant can no longer extract water from the soil. And so again, when we're looking at plant responses to how much water is in the soil, this water potential concept is very important, and hopefully it'll be a little more clear to you here in just a second why that's very important. So if we look at a soil here, and if you look at this graph we've got up here on the slide right now, over here on the right, if I can get my little pointer here to work again, there we go. Okay, so over here on the right, if a soil right after a heavy rain or a heavy irrigation, that soil would be considered saturated. And at that point, basically all the pores in that soil are filled with water. And then soon after that saturation point, once it stops raining or after we finish our irrigation, water is first going to drain out of that soil from the large pores, and we're going to kind of reach this point right here where water is still being held in that soil pretty easily, but there's going to be some air spaces still in that soil from the large pores that are there, and we call that point field capacity. And as I said, that's a point where there's enough water there the plant can easily get to that water and pull it out. So as the soil starts to dry, as we move over to the left here, eventually water is going to start being pulled from the smaller pores and the smaller pores, and eventually we're going to reach this point right here where this other line is called the wilting point, where most of the pores have been emptied of their water, but there's still water in there, but the turf just cannot pull any more water from that soil. And so the soil is, all the water is adhering to the soil, very tightly bound, and the turf can't pull it. And so that's the wilting point. And so again, if we know these pressures, that's all really fine and good, but most of the devices that we have available to us to measure the amount of water in the soil don't really tell us what the field capacity is or what the wilting point is. They're going to tell us how much water's in the soil, and then you as a manager has to figure out for your particular soil and your particular turf grass where these two this upper and lower point is. The field capacity of the soil, and then again the wilting point of the soil. Okay, so just to show you how this kind of works in the real world is that, again, if we look at the X scale here, we're looking at basically the pressure that we were talking about. It's measured in kilopascals, and you don't have to remember that, but as we move to the left, again, that's more suction force that's required to pull water from that. And then on the y-axis here, we're looking at soil water content. Okay, so this is something you can actually measure with one of these devices. And so what I've got here is three lines that represent three soils. The top line, the blue line, is a clay soil. The pink line is a loam soil. And then the brown line here is a sandy soil. And so what we look at here, kind of at this where there's really no water potential or there's no suction force required, you can see that the field capacity of these soils is basically, it's very different depending on the soil type. So the field capacity of a clay soil may be up here in 40 or 50% water content. A loamy soil, which has some sand and silt in it, might be 35%. And then the field capacity for your sandy soil down here may be 18 or 20%. So again, you're still at the same level of pressure, but you're at a much different level of water content. And then you can see as you start decreasing the amount of water content for any of these soils, each of the soils is going to be affected differently in terms of how that affects their water potential. And again, I think it'll be more clear when we look at this here in just a minute how you need to apply that information to your particular facility. Okay, so most of the devices that we're going to look at here today actually measure soil water content and not water potential. And I'm going to show you three devices here. One is a porous block, which basically measures the electrical resistance in the soil. And then two probably better devices and newer devices called time domain reflectometry, or commonly called TDR, or frequency domain reflectometry, which is FDR. Now, I've put a link down here. There's a really good publication that was developed at Cal Davis that kind of covers some of this terminology and even covers some of the measurement technology. Unfortunately, I checked this link today and it's no longer active, but if you'll follow this link and then just type in the title of this paper here, it will actually take you to the correct link. So I apologize for that. I just didn't get that changed before we got this submitted. But again, it's a real nice technical publication that really covers some of this information in more detail if you're trying to really understand what's going on in your soils. Okay, so let's talk a little bit about some of these devices. Okay, so the first devices are porous blocks, and there are a number of these on the market. Things such as this soil moisture meter that you see here. You may have seen these types of devices where you can bury this little porous block in the soil. A lot of times when weather stations have soil moisture sensors on them, this is the type of technology that they use. And as you can see here, relatively inexpensive technology, maybe anywhere from $100 up to $300 for this type of technology. The problem with porous blocks is, again, they're measuring the electrical conductivity of the soil. And so if you have more water in the soil, you have more electrical conductivity in the soil. Unfortunately, and something else affects electrical conductivity, and that is salinity. So if you're in a site where you have very saline water, or if you recently put out a fertilizer application or something like that, then you're going to actually get a reading that's going to look like you have more water in the soil, but it may actually just be that there's more salts in the soil. So you can get some erroneous measurements with a porous block technology. They're relatively insensitive. You don't really get great sensitivity with these things. I've always loved this particular device. This is the kind of technology I can really understand. Dry, moist, wet. So again, pretty easy to see where that is. But again, not real sensitive in terms of giving you really accurate numbers that you might be able to repeatedly go back and use. And because these things are made of gypsum, which is a mineral, these things can break down over time if they're left into soils, and certainly certain types of soils, very high pH soils, will cause these devices to break down over time. So again, these can be somewhat useful. I might use them at my house if I was trying to do my lawn, but I probably would never use this type of technology if I was trying to manage water on a golf green. Okay, so the next two sets of technologies are both relatively similar. The time domain reflectometry, or TDR, and the frequency domain reflectometry, which is FDR. And both of these devices will actually give you a very accurate measure of volumetric soil water content. So again, if you go back to that graph where I showed you the different soils, that particular graph is showing you the volumetric water content of those soils and how that relates to water potential. And again, there's several devices on the market now that's being marketed in the turf industry, and all of these are similar in that they have some type of probe that you stick into the soil, and then it has some type of data logger that then you would record or see what the volumetric water content is in that particular soil. So again, these things, basically the technology behind them is a little more accurate than what we saw with the gypsum blocks. Basically, they use a high frequency electromagnetic wave that it pulses into the soil, and the speed at which that wave is reflected back into the meter or back into the probes will give you an indication of the amount of water that's in the soil. And so again, these are much more accurate, and they'll actually measure volumetric water content. And so one of the things that you can also get with these technologies is that some of them can actually also measure salinity. So if you're in a site where there is a high saline issue, then you can also get a salinity measurement in addition to your volumetric water content. The FDR probes, the only technology that's currently out there that's an FDR technology is this particular device. It's a theta probe, and again, it's very accurate, probably more accurate than even the TDR. And one of the things that this technology has that's also very good compared to TDR is that it also can eliminate salinity effects on the water content measurement, whereas TDR can be affected in some cases by high saline content soils. So again, this is probably the highest end technology in terms of accuracy, but it's also, as you might guess, the most expensive of all the technologies to measure soil water content. Okay, so if we're going to use one of these probes, and again, there's several different out there, and I'll give you some examples and some prices here in a minute. Moisture probe is you have to calibrate that probe for your particular site. And again, if you go back to that slide thinking about different soil types, every soil is going to be at a different level of water potential at a different water content. And so you need to know for your particular soil and also for your particular turf grass what those key numbers are going to be to relate the water content to the actual water potential. So this is kind of how you would want to go through calibrating your probe at a particular site. So the first thing you'd want to do is irrigate the turf thoroughly. You want to try to get the turf as close to being, the soil to being saturated as you can. And then you're going to let that soil drain for about an hour, and then you're going to take a moisture reading. And so hopefully that reading is going to be relatively close to field capacity. So after that hour, the large pores have drained, and what you're left with is the soil that's going to be at a field capacity level. And then you're going to start taking readings on that soil basically twice a day after you've irrigated, hopefully with no rain added to it, and let that soil start drying as you're taking these moisture readings. And you want to be careful to note if the turf is showing any moisture stress symptoms. And then you would basically want to continue taking those readings until the turf shows some type of drought stress symptoms, whether it's a dry spot or some leaf firing or something that you know that the turf has reached a point where it's starting to wilt. And so if you think back to what we talked about earlier, again, this first number here that we're going to get is going to be our field capacity. The last number we're going to get right down here when the turf starts showing stress is going to be the wilting point of that soil. And again, you're going to be able to now relate those two water potential measurements to the soil water content for that particular soil. And again, it's very important that you calibrate for each soil type. If your tees are built differently than your fairways, if you have different types of greens, if you have 9 holes that are soil-based greens and 9 holes that are sand, again, you're going to need to make sure you calibrate for each of those soil types. And again, the grass is going to also affect it because some grasses are going to be more drought tolerant than others, and so they're going to be able to go to a lower volumetric water content before they start showing signs of drought stress. Okay, so this is might be what that calibration looks like, and I've got 3 lines here. The top line, the yellow line, is a soil-based push-up green. The pink line is an older USGA green, maybe 10 years old, and then the blue line is a relatively new USGA green. And so, again, this is our volumetric water content over here on the left, and so 1 hour after we irrigate it, this should be the fill capacity of these 3 soils. So for, again, your new sand green, it's about 25%. For your soil green, it's almost 45%. And now as the soils start drying and start losing water, we're basically measuring soil water content twice a day, and we're looking for the point where we finally get wilt symptoms. So if we advance that now, we can see that the sand, the older green and the newer green, the soil-based green, they're going to show wilt at different times and at different volumetric water contents. Okay, so again, we've got our field capacity number here. So let's look at maybe just this new USGA green. and then we reached wilt when we got right here. So our fill capacity is going to be somewhere around 25%, and then our wilt showed up about 8%. Now obviously when you're trying to manage soil water on a putting green, you're really not wanting to get into this wilt range very severely. I mean, you can take a little bit of drying and browning on the green, but most of the time you're going to want to try to irrigate at some point before you reach wilt on that particular green. So for this particular example, maybe we're going to consider 10%, maybe even a little higher, 11 or 12%, to be our lower threshold number where we would then want to irrigate that green. And then again, if we come out here and measure the soil water content on another day when we're not calibrating and we find that we're at, say, 18%, then at that point we would know that we still have a volume of water in that soil that we're going to be able to use before we reach our wilting point. So again, those are the two numbers that you're trying to get. Your upper number, which is your fill capacity number, your lower number, which is going to be basically something above your wilting point. And again, you're going to have to kind of decide how close to that wilting point you're willing to go before you decide to add water to that particular turf. So again, there's a number of technologies that are out there, a number of different companies. If you go to the golf show, for sure, there's most of these companies are represented there. But again, you can look at these and get online and search them and see what their cost and their and some of their maybe their bells and whistles that they might have with their particular device. But you're probably looking at somewhere between about $500 upwards to about $2,000. Now, I know some people choke when they see the price $2,000. When I was a graduate student back a couple of decades ago, a TDR unit, you couldn't buy one for less than $10,000. So it really wasn't a technology that you could even use from a management standpoint back then. It was only a research device. Now we have these devices that certainly under $1,000 you can get a soil moisture probe, a TDR-based probe that you can use very effectively to help you manage water on your golf course, or any other turf site for that matter. Now, I like to show this graph because this is always where the eye rolling starts, but this is an important piece of information because some people will say, well, they swear by one particular probe over the other. This was some data that Dr. Bernd Leinauer developed several years ago where he tested about 10 different TDR probes to see how their actual water content calibrated against a measured water content. And what he found is that all of the devices, even though their calibrations were slightly different from each other, all of them were very well correlated between actual water content and volumetric water and measured water content. So what does this mean to you? Is that all of them can be used very effectively. None of them really have some type of technology that makes them more accurate than others. So again, price shopping I think is still a pretty prudent way to go about when you're looking at these particular types of technology because they all basically are well calibrated against themselves. Okay, so how would you use these things? Well, there's a number of ways that we see people using soil moisture probes, and usually when we ask audiences how many people have these things, certainly in the golf industry, I'd say 40–50% is not an uncommon number to people that are using moisture probes. But again, you can use them very effectively for hand watering to go out and see, right where you are in terms of whether you need to do any hand watering or even syringing. Certainly scheduling irrigation is a very important thing you can do. Irrigation uniformity, we've actually had some people do irrigation audits using soil moisture probes rather than doing the catch cans. You apply the water and then you go out and just measure soil moisture around a site to see how uniform the soil moisture is after an irrigation event. Certainly if you have drainage problems, you might be able to find those. A lot of people are interested in knowing how wetting agents are affecting water holding capacity in soils, and so you can use soil moisture probes to see if water's being held more up in the upper part of the surface or if it's being moved down. Again, these probes can all be used very effectively for those types of evaluations. Again, some of the limitations, again, they aren't cheap. I still recognize that $1,000 is $1,000, so they certainly are more expensive than gypsum blocks. One of the problems you'll get into is that if you have very dry native soils, these rods will be very difficult to insert it into those soils, and so a lot of times you'll damage the rods or you can break them. In most of the cases, they're not terribly expensive to replace. But again, if you're trying to use these in very dry soils, you're probably going to have a more difficult time than you might be in like a sand-based green that's got a little moisture in it. And the rods will wear out over time if you're using it a lot, and you have to replace those. But again, the cost on those are usually not too great that it really adds a lot to the instrument. There are some other technologies that are being developed now that can use the same type of information or the same type of technology. Some of you may be using wireless sensors that are buried in the soil all the time that can give you soil moisture readings. And in some cases, those are tied also to automated irrigation systems. The number of different companies now that have that type of system. And again, there's some limitations to that as well, but certainly it's a technology that I think we're going to see more and more of in the turf industry as we move forward. And then finally, you can develop moisture maps that can be useful for, again, making maybe trying to sell the idea that, irrigation systems are not working properly or there are soil problems that need to be addressed. And we'll get back to that topic of moisture maps here in just a few minutes. Okay, I think we'll keep moving here for a few more minutes, and then we'll stop maybe and have some Q&A if there are any. So now I want to move from soil measurements to light measurements. Now, the human eye and plants are very different in terms of how light is perceived. The human eye, what we see, is more affected by light that's in the middle of the visible range, kind of in the yellow range. Even though we see the entire spectrum, that's the color that we actually see the best with our eye. Plants, on the other hand, if you look at this graph at the bottom, if you remember back from one of your basic botany classes or plant physiology classes, they need light that's in the blue range, and then over here kind of in the orange and the red range for photosynthesis. And so there are a couple of different types of light meters that are out there that can be useful to you. But just understand that some light meters, like a standard light meter that I'll show you here in a minute, they basically look at light across the entire color spectrum, whereas a PAR meter, which is measuring photosynthetically active radiation, is filtering out everything except light that's in the blue range and then in the red range. So it gives you a much more accurate estimate of how much light you have there that plants actually can use. And so again, the first type of light meter that you might come across and that you can actually put to use, one of your local retail stores, certainly a camera shop for doing photography. And again, these are going to be basically measuring the total irradiance on the turf. So all the visible range of light is going to be measured. And so again, not all of that is plant useful, so about only 50% generally of the total irradiance is going to be in this photosynthetically active range. And so again, it can be useful, but you have to be aware that you could get some information that maybe doesn't give you a true reflection of how much shade you're actually dealing with. And the reason for that is that, again, if you're dealing with shade from trees, which is the most common form of shade that we see out there, is that these trees here, they want the same exact light that this turf down here wants as well. So they're basically going to be filtering out a lot of the red and a lot of the blue light for their own photosynthesis. So the light that actually finally reaches that turf canopy, even though it may be only reduced 50% if you look at the total irradiance, it could be reduced as much as 75 or 80% when you start looking again at these very important blue and red ranges of light. So again, a PAR meter is going to be a much more accurate measurement of actually how much shade you've got out there. And again, this is another technology similar to TDR that is much more cost effective today. You can actually buy a PAR sensor for really probably even less than $200 now that you can go out and actually get photosynthetically active radiation measurements very effectively. And again, when I was a graduate student, these things were in the thousands of dollars to get a PAR sensor to measure that type of light. And again, the PAR sensor is already going to filter out all the other light, so it's going to give you a much more true reading of the effects of shade on plant productivity. So again, if you're really dealing with a lot of shade problems, this can be issues are, and then use that again in presentations maybe to your committees or members to try to make some changes at your facility. Now, some of you may have used really high-end technology that's out there, a company called Arbor Common. Arbor Common's been around now for probably close to 20 years, but they can basically come in and look at a site, and in this case we're looking at a golf green, and this golf green has got a number of trees around it, and they can basically map the shade patterns on this particular green based on the location on the earth and the size of the trees and the angles that they are away from the green. They can give you these detailed shade maps that will show you how much sunlight you're getting at various places on a particular green. Again, Arbor Common is a great technology. We've supported them and worked with them over the years, but it's not cheap, and so it's certainly not something that everybody can go out and maybe afford to do on a lot of different golf holes at their facility. So the question is that if you're dealing with a site like this, can you do some mapping of the light effects without having to take it all the way up to the technology that would be something like Arbor Common? So we're going to talk just a little bit about how you might go about doing something like that. So again, if we took a green, and let's say it's shaped like what we've got over here on the left, and we wanted to take light measurements of this green. Again, we're not going to be able to get a picture of what's happening over the whole day like Arbor Common can do, but we could come out, say, early in the morning and set this thing up on a grid and take light measurements along this grid so that we have basically light patterns across this entire green. And so if we took those measurements using our PAR sensor, created a spreadsheet like this, you basically can then calculate the percent of full sun based on first, what your maximum light level is at that point in time. So I've got an example here where 1950 micromoles was our maximum PAR light for this particular measurement. And then in this particular spreadsheet, it's showing that's 100% light. And so all of these other calculations down here are showing you the percentage of that full light that you've got at that particular point in time. And so again, if some of you are interested in getting this spreadsheet available to you, I'd be happy to send it to you, and I've got some other things in there that you can use as well for doing this type of measurement and mapping. And so again, you can see on this green that we've got an area down here where light levels are very low, and they're down in the 10 to 20% range in terms of the percentage of full sun. And so if you took that information and put it out onto some type of spatial map, you could get a graphical presentation to then be able to take to management and show them what type of light effects you're dealing with on this particular site. And so again, one of the things that's very important either with soil moisture data or with light data is to be able, again, to put that data in a form that somebody that doesn't know anything about turfgrass management can maybe look at and say, okay, I understand now. And so there's a number of programs out there to do that, but in each case what you're going to use is some type of graphing software that allows you to take spatial coordinates like on the XY grid like we just looked at, or in some cases some of the technologies that we're looking at here today already have actually GPS units on them that you can actually get a GPS coordinate from your when you're collecting your data, and then you can actually develop these maps based on a GPS coordinate. Okay, so what kind of software is available? Well, there's a lot of products out there that will do this. Even a basic program like Excel can do some spatial mapping. It's not real pretty, but there's some other specialized softwares that can make that data much better. One of the ones we're going to talk about today is a product called DeepLot. There's actually a freeware version of this that you can download, and you actually can put it into your Excel. So you basically put your data into Excel, and then the DeepLot will actually develop the spatial maps for you, and I'll show you what some of these look like. And then there are some specialized spatial mapping softwares out there like Surfer that will do a lot more detailed information, but they're also much more expensive types of software. And so again, with some things like Excel and DeepLot, you probably already have this on your computer, and then a free add-on you can get some pretty nice maps that you can use to map this type of data. Now, there are also some other options out there. Spectrum Technologies, which has been one of the leading companies selling these types of instruments to the turf industry, they actually have a specialized mapping software that's actually available on the internet called Spec Maps, and you basically take your data that you collect at your site, you upload it to their website, and then they'll generate these different types of maps for you, spatial maps that you can use in your presentations or in your decision making. Okay, so this is an example of the Spec Maps software, and again, this is a subscription-based system, so it's about $200 a year to use this this online version. But again, this is a soil moisture map developed on a putting green, and this one was actually used using GPS data. But again, what it does is it develops this spatial map that you can now see. The legends are the lighter colors are lower soil moisture data, and then the darker blue colors are higher soil moisture, soil volumetric water content. And so now you can show areas of a green that are obviously too wet, maybe areas of that particular green that are too dry. And then again, maybe this is an irrigation problem, maybe there's a drainage problem. Again, this would be a good way to document those effects on a particular site. Okay, so again, if we go out and want to just collect this data on our own, you need to first collect data on a grid, just like I showed you earlier. So you have an X grid or an X direction and a Y direction on your grid. And again, you don't have to go out there and mark this off with tape. Usually what we do when we're mapping is that if the green is, let's say, 60 feet wide, I might take 2 steps and take a measurement. Take 2 more steps and take a measurement across the green, turn around and do the same thing coming back. And so you can do this without having to go out there and put a lot of effort into really gridding this thing out on a very accurate grid, and you'll still get the same type of information. And so again, once you drop this type of information into an Excel spreadsheet, again, you have your X coordinates going across the top here, your Y coordinates here, and then these numbers, the data you collected, become a Z coordinate in this spatial mapping software. And so regardless of what software program you use, all of them are either going to have X and Y coordinates and then the Z data value, or you're going to have this data value be associated with a GPS coordinate if you're using a GPS unit when you're collecting your data. Okay, so now again, this is the basic Excel program right here, looking at a spatial map of some soil volumetric water content. Again, not the prettiest thing in the world, a little clunky, but again, you can still see dry spots here, you can see wet spots here, and then another dry spot down here. So again, you can still get a visual map even using something as simple as the spatial, the XYZ mapping feature that's in Excel. The next map here is actually the same data with using the DeepLot add-on software that I mentioned earlier. Again, there's a full version of DeepLot that costs $70 that you can download from this website, but we found that the DeepLot Junior, which is a free version, really does everything you'd need to do to develop these types of space. And again, you can still see areas that are wet, areas that are dry. And again, these are your X coordinates here, these are your Y coordinates here, and then this is your actual data. So if you've ever looked at a topography map or something like that, it's really very similar in how this works in terms of mapping and looking at the information that you have. And so again, if we were looking at light measurements, something you might do is if we go back to that grid I showed you earlier, if you went out and collected data at 8 o'clock in the morning, and then again at noon, and then again at 4 p.m., you could develop a spatial map for each of those times during the day. And again, you could show where shade problems are occurring in the early parts of the day, later parts of the day. And again, if you developed one of these for each hour of the day, you could show a full picture of how light is traveling across that particular green. And so again, this is a very effective way sometimes to show people, that there really are shade problems on that particular site. I mean, the way I always explain it is that, the guy that complains the most about that particular site or that green, he only goffs in the middle of the day, so he never sees the shade problems that you might have out there. And so again, this is a very good way to graphically demonstrate what's happening over the course of a day in terms of light activity on that particular site. Now, the last thing I want to talk about here in light, and then we'll take a little break here for some Q&A, is something new that Spectrum Technologies released here a couple of years ago, and this is kind of a cool little device. They call this a daily light integrator. And basically what this device does is it has here in the top of it one of these little PAR sensors, and you can see it over here on this side as well. And so you go out and you install this thing into the soil, at the canopy height of the turf, and then basically that light sensor collects light data for that location over the course of an entire day. And so rather than the previous version where I was showing you were getting a snapshot at different times of the day, this actually will add up and measure how much total light you're getting over the course of a day, and then we'll give you that number here at the end of a 24-hour period, how much total light had struck that surface. Now, one of the downsides to this technology is that, again, it's not terribly sensitive. You're only going to get these kind of moles of energy here that go from 0, which would be no light, upwards to above 30, which would be, again, a very full sunlight site, maybe even, in an area like the desert where you were getting no cloud filtration or anything like that. But again, if you had two of these things and you had one in an area that you have shade problems and another out in a full sun site, maybe on the full sun site you're up here at 30, maybe on the shaded area you're down here around 4. So again, you can get an idea of the percent shade that you're actually experiencing at that site. And again, it's calculating that over the course of an entire day. And so again, if you look at basically the light that's striking a turf surface, even the angle of the sun really reduces the percent of irradiance that you're getting. So the maximum sunlight that you're going to get is when the sun is at solar zenith or at solar noon, the middle of the day. And so every hour before and after that, you actually will get a reduction in light levels just due to the angle of the sun. And so again, what this daily light integrator does is it basically measures how much light you had here the first hour, the second hour, and then it basically sums that up for the entire day and tells you how much total PAR energy struck that surface during the course of one day. Now, you can buy a 3-pack of these for about $190. So again, they're not terribly expensive. They're not giving them away either. But again, this is a nice little way to go out and you could put these maybe on a couple of spots where you're experiencing shade problems, and then put another reference out in full sun, and you can probably get a pretty quick read in a 24-hour period of how much shade you actually have on that particular site. Okay, I think, Frank, if we want to, we could stop a minute and see if there's a question or two. And
Yeah, Mike, we got a question in from Richard from North Carolina. And basically, Richard wants to know, can the wilting point of turf on a green change according to the chemical program you use? So I'm thinking what Richard's kind of got in mind is like, is that wilt point calculation that you would try to calibrate off your moisture meter, would that change depending on, say, like a different fungicide program or nutritional program or some of these like plant health type materials?
Well, since it's a Bayer webinar, I'm sure the stress guard would make it, it'd be awesome after that. So, but certainly any cultural practice that you do that changes the physiology of the turf and changes, the rooting capacity of the turf, any of those things, you're going to have a slightly different wilting. A bent grass green, let's say in May, when you have a very extensive root system, the volumetric water content that you see wilt at may be much lower on that particular at that particular time than maybe midsummer when that root system has been compromised. And so once the root system becomes compromised and becomes shallower, then that plant in general is going to be more sensitive to stress. And so it would be a good idea that if you know you're going to go through those peaks and valleys during the year, to kind of get a general idea of what that wilting point would look like during various times of the year. And certainly, your fungicide program, if that's again protecting the root system, if it's enhancing the photosynthetic capacity of the plant because it's protecting the plant or providing some other biochemical effects, then certainly that plant is going to be able to go to a lower soil water content before it experiences wilt.
Awesome. Thanks so much, Mike. Why don't we go ahead and proceed with the last section of the seminar today? Okay,
that sounds good. All right, so where I want to finish up here today is talking about phone apps. And again, this is a very rapidly changing technology. So again, I haven't haven't looked at all of them, but we'll at least go through a few of the ones that I found to be the most interesting, and a couple of them that are pretty useful. Okay, the first one I want to talk about is the iStamp. And basically this is one that you can buy online for 99 cents, so it's relatively cheap. It's only, I think, available on the iPhone. I'm not sure if it's available yet on Android. But basically it's an app that will turn your iPhone into a stent meter. And so the iPhone, because of the gyroscopes that it has in it, knows at the angle that that phone is going to be set at. And so basically it uses the phone as a clinometer, and you can set the phone to a 30-degree angle, roll the ball off of it, and then you measure the distance the ball rolled, and then the calculator that's in the app will convert that to feet. Frank, do we have time to watch the video?
Yeah, sure.
Okay, so basically I've got a video here. This was something that Larry Stoll out at Paysturf in California developed, and it's really probably does a better job of explaining this app than I ever could. So over in the dial-in information, there's a URL, and so if you'd like to watch the video right now, just copy that URL into your browser, and we'll kind of watch it together, and then when we get back, I'll make a few comments, and then we'll move on. Is that okay, Frank? Is that all we need to do?
Yeah. Mm-hmm.
Okay.
Just a reminder, if you're having trouble accessing the video, the iStamp link to the YouTube video is just on the upper right-hand side there underneath the picture of Dr. Richardson. So it's about a 5-minute long video, but Mike, maybe you have some comments as we're going through it. So.
Well, I guess the first comment that I would say is watch how you have to measure it with the iPhone. That's certainly, I would say, a somewhat tedious process.
Yeah, as I'm watching the video here, Mike, on a separate browser tab, basically it's just got a nice setup of Dr. Larry Stoll showing basically how to operate the application, and kind of showing basically what the procedure is. Use the iStamp on the iPhone there, and I have to admit it looks a little painful. So.
Well, but I'll make this one comment about the iStamp. It's one of the coolest little apps I've ever seen. I mean, it's just when I saw it, I thought, wow, what? I mean, you know, it's pretty creative that somebody came up with this idea. Even though functionality is probably not real good, it's still I give them an A for effort.
Yeah, for those of you guys who aren't familiar with Pace Consulting down in San Diego, Larry Stoll and Wendy Galernter are pretty great as far as it comes to producing these short videos for the industry. And so you can see there through your YouTube page that you'll probably be able to find a few videos that Larry and Wendy have produced as far as having some just short informational sessions on kind of tips and tricks and little gadgets and so on and so forth.
Okay, well, I think we're getting pretty close to the end here. He's got a few comments towards the end, but maybe we'll get back over here and get on the PowerPoint and keep moving here. So if you heard one of Larry's comments in there, he compared the iStamp to Farts for Friends as another app that was pretty similar in terms of what he thought was the quality of it. And I would say that's probably my opinion too. It's really not a very useful application, but it might be something to entertain your friends at dinner parties or something. So again, probably not something that you hope too many people are going to be using out on your golf course. Now, I will give the folks at Iowa State credit. They actually went out and measured some green speeds, comparing the iStamp both on the iPad 2 to the iPhone, and then also the iPod Touch, which is similar to an iPhone. And then they compared the data that they got with a couple of different stent meters that they had at their site. And the iPad actually wasn't too far off, but the iPhone actually pretty grossly overestimated. But again, if you're managing greens and your members want to know, 14.5 sounds pretty good to me. So maybe the iStamp has some application there that you can really bump up your green speeds without actually having to lower your mowing heights. So again, that's probably one that you're probably not going to be able to use a lot. So let's move to some phone apps that might have a little more application. Now, the first one here is one that's been developed recently by the University of Georgia. It's called the Turfgrass Management app. Basically, you can download the app for free, which has some real base information on it. But if you want their full content, it is a $20 per year subscription for the content. And basically, you can kind of see the home screen here, diseases, insects, weeds, etc. So if you were battling a particular insect, if you go into that section, you'll find pictures of that particular insect, information on life cycles, chemical control options, cultural practices that you might implement. So again, it's a very nice collection of content and information. It's somewhat like going into a web browser, so it's not like a decision maker. It's just more that you'll have that content available to you through an app on your phone, rather than maybe having to try to go to someone's website, which I think it's actually not an add-on. It's a separate app, but it was kind of the second generation of that. This is a really wonderful little app here called the Turf Management Calculator. And basically this you need to do to manage a turf site. And so again, if you look over here on the left, you can see things like calibration, combining products and getting calibrations on that, all kinds of conversions. So again, a whole range of topics. And so in each one of these cases, for example, if you were doing a calibration and you wanted to know how much product you needed for a particular application, you would go in here and then you would just start entering the information in the units that you want to use, how much product you want to put out on a given area, and then it'll calculate how much product you might need. It has a really nice function for calibrating sprayers and spreaders. You just enter all the information, such as how much volume you collected in a nozzle, ground speed, and things like that, and it does all your calibrations for you. So again, this is a very nice little app. $6 is the cost of it, and again, something that can be very useful for you as you're out managing your facility. A similar app that I came across this year to the one I just showed you is called Turf Caddy. Again, it kind of does the same basic thing, does a lot of calibrations, conversions, things like that for you. A little more expensive. The last time I checked, it was selling for $29. So again, I'm not sure what it'll do that makes it $25 more useful than the one from Georgia, but again, something you might want to look at if you're looking out there. And it may have some functions that that they can't do with the one out of Georgia, but it looks to be very similar in terms of the types of things that it'll do. Okay, the next one here is one of my favorites. This is one that I probably have recommended and seen more people actually put to use than any other app that's out there. It's called Sunseeker. This app was originally developed actually for people that were designing houses, and they wanted to find out, okay, if I site a house here, where do I want to put windows to take maximum advantage of morning sun or afternoon sun? And so basically this app uses the GPS locator on your phone, and it locates where you are on the earth. And then basically, if you look at this kind of overview right here, it shows you where the sun is going to track in relation to that particular position. Now, even that's kind of cool just looking at that, but this is on this particular day. It's going to show you where's the sun going to come up, where is it going to set in terms of the angle from your particular location. But the thing that's really great is that you can actually go into a different function on this app, and you can actually use the camera on the phone to actually look away from the site that you're standing on. This is a picture I actually took yesterday out on a golf green, where I was standing in the middle of a golf green, and basically it's showing me over here 3 different lines. This red line is going to be when we reach the summer solstice, when the sun is at its highest point. The blue line down here at the bottom is where the sun is going to track during the winter solstice when it's at its lower point. And this yellow line here in the middle is actually showing you where the sun's going to track for today. So again, we're getting kind of close to the summer solstice here, and it's showing where the sun's going to be tracking at 8 o'clock in the morning, 9 o'clock, and you can continue to turn and look and see at any point in the day. The base of this tree last year looks to have been a good idea based on the amount of shade that tree was probably throwing on this green, at least during the middle of the summer. And so, again, this is an effective way, and it has a feature that allows you to use the camera phone once you've got it positioned where you want it to actually take a picture of that, save it onto your phone, and when you get back, you could actually develop a presentation to show someone exactly where the sun tracks behind a particular tree. And again, the nice thing about this technology is that you can look really at any time of the year, and it'll show or the summer solstice. So again, this is a really handy little app. I think the price on it has actually gone up a little bit. It was, I think, originally about $3. I think it's about $5 now. But again, a very cool app for going out and mapping, trees that might be potentially causing shade issues on a site. For those of you that maybe follow some of the other blogs and things out there, this was something that TurfNet put out a couple of months ago. This was a superintendent out of Pennsylvania that actually used this app to make a case for removing a particular tree on their course. And once he used this to demonstrate to his membership how much shade or how the sun was tracking through a particular tree, he was able to actually get them to actually remove that tree to improve the turf maintenance there. So again, this is that particular app in action by one of our peers out there in the golf course maintenance industry. A couple of more apps that you might find useful. This is a clinometer. This is useful for a couple of reasons. It's only 99 cents, so it doesn't cost a lot. I found it to be very effective at home when my wife wants to have a picture hung nice and level. I can use this app to make sure I'm getting it perfectly level. But from a turf management standpoint, one of the things that I've seen some guys do with this is they can use this to really look at potential pin placements on a golf green. Again, if you decide that there's a threshold, maybe it's 1.5 or 2%, or 1.5 or 2 degrees that you would say is you don't want anything over that for a golf hole placement, you could use your phone to just go out and lay it on the surface, and it will tell you how far off of dead flat you are for a particular pin placement. We've also seen this used by baseball field managers to make sure when they're installing bases, pitching rubbers, and things like that, that they're getting those perfectly level. And it's a very, very accurate level that can turn your phone into a really nice little level. This is another pretty cool little app where you can actually go out and measure areas using your phone. Basically, it uses a Google Earth type technology where you'll see your site on the phone, and then you go in and you start placing waypoints or placing place marks around the site, and then eventually, once you close that site up, it will actually calculate how many square feet, how many acres a particular location is. So this one's called Planimeter. It's about a $4 download, and there's several others out there that do a similar type of function. But again, if you like to do some basic mapping of areas, this can be a function that you can put right on your phone. Some of these are also available on the Android market. If you have an Android smartphone, the turf management app from Georgia is available there. The Sun Seeker is called Sun Surveyor on Android. So again, if you're looking for that on your Android, that's the same exact app. Planimeter is also available out there, the clinometers, and again, there's a number of versions of this particular app out there for various phones. So again, some of these are not available on Android yet, but my guess is you'll probably see them coming in the next year or so. Okay, Frank, that's where I was going to stop, and hopefully we've got a minute or two for another question or two.
Yeah, great. Thanks, Mike. The only other question that I've got here today is a question came up is, how come there were no good turf applications for BlackBerry?
That is a good question. You know, I think BlackBerry has generally had a kind of just a different approach for what they use their phone for. I think it's really been a business phone that has been used primarily for, you know, whether it's exchanging data securely, emails, and things like that. I think that's just been more of their market than developing, you know, some of these apps that are associated that you might just use for fun or for other applications or work. But I don't know. You'd have to ask them.
Thank you, Mike. If there's any other questions for Dr. Richardson today, please take advantage of the Q&A box there on your lower right-hand side and type in a question as we go along. Great. Well, as we're doing that, again, please type any questions if you've got them. But in the meantime, here's the 9-digit code for the continuing education credits from GCSA. And that code is 999-9119-14755. Again, that's 999-9119-14755. Great. Well, Mike, I think you've done such a wonderful job today as far as just showing us some new technology that's available. And any questions from the team here at Bayer? Okay. If not, I'd like to thank my colleagues, Mr. Jimmy Johnson and Lawrence Mudge, and the folks over at Global Prairie today for helping put on the seminar. And also, Mike, thank you very much again for your presentation. And if, again, if you have a chance to check out our Back by Bayer website for a video recording of this webinar, as well as other webinars from our previous series, it'd be a great thing to check out. Okay.
There is a question.
Yes, go ahead.
Another question came in from Dave. Are the apps all at the iTunes store? So do you know if any of these are available that way?
Yes, they're all available that way, Jimmy. So yeah, just go to the iTunes store, type in that particular name, and it should pop right up.